Okay, I wanted to start on these two theorems. For your first homework of the week, you don't really need these, but it's going to come in handy in the near future. Now, we don't prove these two theorems, we just apply them. Okay, so the parallel lines theorem. Okay, so two lines are parallel if and only if they have the same slope. So that means if lines have the same slope, then they're parallel. And it also means that if lines are parallel, then they have the same slope. Okay, so lines are parallel if and only if they have the same slope. Okay, now the perpendicular lines theorem. Okay, perpendicular lines do not have the same slope, because if they had the same slope, then they'd be parallel. Perpendicular lines have slopes that are opposite reciprocals of each other. Okay, now, what do we mean by opposite reciprocals? Okay, well, they're reciprocals that have different signs. Okay, so opposite reciprocals of each other. Okay, so for instance, let's suppose I had the fraction 3/4. Then its opposite reciprocal, okay, would have to be -4/3. So notice, remember, when you take a reciprocal, you switch a numerator and denominator. So I switch the 3 and the 4 to get 4/3, and then I change the sign from positive to negative. Let's suppose I had a -10/13, like that. So its opposite reciprocal would have to be positive 13/10, like that. Okay, let's suppose we take the opposite reciprocal of -1/5. So its opposite reciprocal would be a positive 5/1, or just 5. Okay, so obviously 5/1 is not a reduced fraction, 5. Okay, so -1/5, okay, and +5 would be opposite reciprocals of each other. Let's suppose I had a slope that was an integer. Okay, I don't know, let's just make it a +6. Okay, so 6 is the same as 6/1. Okay, so if I take the opposite reciprocal of 6/1, I get a -1/6. Okay, so 6 and -1/6 would be opposite reciprocals of each other. Okay, so if lines have the same slope, then they're parallel. If lines have slopes that are opposite reciprocals of each other, then they're perpendicular. Okay, and remember, perpendicular means they intersect to form 90-degree angles. Okay, so you'd have your little box there, or just a 90 degrees. Okay, perpendicular, they form right angles. Parallel, they do not touch each other. Okay, like that. All right, so we need these to determine whether or not lines are parallel or perpendicular, okay, in the coordinate system. So it wants us to take a look at this, and it says, okay, are the lines parallel? Well, if they have the same slope, they're parallel. Are the lines perpendicular? Well, if they have slopes that are opposite reciprocals of each other, then they're perpendicular, or neither. So if they're neither parallel nor perpendicular, then we would just say neither. Okay. All right, so let's see this guy right here. Okay, I'll let this guy be line number 1 and this guy be line number 2. Okay, so if I'm doing the slope of number 1, okay, the slope again, delta y over delta x. Okay, so I'm going to go this point minus that point. Okay, so delta y would be 6 minus 10, which means my delta x has to be 0 minus 5. 0 minus 5. Okay, so I get a -4 over a -5. And the negatives cancel each other, so I get a +4/5. Okay, so this slope right here is a positive 4/5. Okay, then I do the slope of line 2. Okay, so I do line 2 here. Okay, so my slope, which again is delta y over delta x, and I'm going to go these coordinates minus these coordinates. So delta y would be 1 minus 5. So 1 minus 5. Then I'd have to go -2 minus 3. -2 minus 3. So I get -4 over -5, which of course the negatives cancel each other off, and I get 4/5. Okay, so we look at those slopes and notice they're the same. Okay, so we go back here. What happens when when lines have the same slope? That means they're parallel. Okay, so these two lines would be parallel to each other. And we know we have a symbol for parallel. It looks like an 11. Okay, so in number 1, the two lines are parallel. Okay, so let's do number 2 here. Okay. All right, so in number 2, I'll let this guy be my line number 1, and I'll let this guy be my line number 2. Okay, and so I have to figure out what's the slope of both of them. Okay, so we go, let's see, line number 1, and I'm going to do my slope. So again, it's delta y over delta x. Okay, so I'm going to go these coordinates minus these guys. So my delta y would be -4 minus 8. So I have a -4 minus 8. And then my delta x would have to be 3 minus a -1. 3 minus a -1, like that. So I'm going to get a -12, okay, over a +4, which reduces down to -3. Okay, so the slope of number 1 is, or line number 1, I should say, is -3. And I do the slope of my second line right here. Okay, so again, I say the slope is delta y over delta x. Okay, and I'm going to go these coordinates minus these coordinates. So delta y would have to be 7 minus 11. So 7 minus 11, which means that my delta x would have to be 0 minus 12. So I get 0 minus 12. Okay, so I get a -4 over a -12. The negatives cancel each other off, okay, and I reduce, so I get a +1/3. Okay, so we look at these guys. Clearly they're not the same, okay, so there's no way they're parallel, but are they perpendicular? Okay, are these guys opposite reciprocals of each other? Well, okay, notice if I take -3, that's the same as -3 over 1. And if I look at that guy and +1/3, they are opposite reciprocals of each other. Okay, so since the slopes are opposite reciprocals of each other, these lines have to be perpendicular. Okay, so these guys are perpendicular. Okay, all right, so these two lines would intersect and form a 90-degree angle. Okay, so now we're down to number 3. Move this up a little bit. Okay, well, let's see. I'm done with number 2, on to number 3. So again, I'll let this guy be the first line. I'll call him number 1. I'll let this guy be the second line. I'll call him number 2. Okay, so let's see. If I do the slope of number 1, okay, so our slope, delta y over delta x. Okay, and I'm going to go these coordinates minus these coordinates. Okay, so I go 1 minus a -1 for delta y, 1 minus a -1. And delta x would have to be -3 minus 0. -3 minus 0. So I'm going to get a 2 over -3, and we don't like a negative in the denominator, so we put it up front or up above. So I get a -2/3. Okay, so the slope of the first line is -2/3. Now I got to do the slope of this second line, number 2. Okay, so again, my slope is delta y over delta x. Okay, So I'm going to go these coordinates minus these coordinates. Okay, so my delta y would be 6 minus 0. I'll go 6 minus 0. Okay, then my delta x would be 9 minus 5. Okay, 9 minus 5. Okay, so I'm going to get a 6 over 4, which reduces down to a positive 3 halves. Okay, and I look at these guys. Okay, clearly they're not the same. Okay, if they were the same, then the lines would be parallel, and they're not the same. Okay, so we ask ourselves, are they opposite reciprocals of each other? Well, if I take that guy and change its sign and then take the reciprocal, I get 3 halves. Okay, so they are opposite reciprocals of each other, which means that they have to be perpendicular. Okay, so these guys are perpendicular. Okay, which obviously means that they intersect and form 90-degree angles. Okay, let's do number 4. Okay, move this guy up a little bit. Let's see what's going on with number 4. And I'm already done with number 3. Once again, I'll call this first guy line 1, and I'll call this second guy line 2. Okay, so if I find the slope of line number 1, again, delta y over delta x. Okay, so I'm going to go these guys minus these guys. So delta y would be 2 minus 9. 2 minus 9. And that means delta x would have to be 5 minus 5. 5 minus 5. Okay, so I'm going to get a negative 7 over 0. Now remember, okay, from the last video, when zero's in the denominator of a fraction, okay, that means we have an undefined, okay, slope, or it's DNE, it does not exist, okay? So this guy, reduced, okay, we would write undefined or does not exist. So does not exist. Now, the only type of line that has a slope that's undefined or doesn't exist is a vertical line. So this guy is certainly a vertical line. Okay, so the first line is a vertical line. Okay, and then we look at number 2. Okay, so I got to do the slope here. So again, slope delta y over delta x. Okay, so I'm going to go these guys minus these guys. So my delta y would be negative 2 minus 0. Negative 2 minus 0. And then my delta x would be negative 3 minus a negative 3. Negative 3 minus a negative 3. Okay, so when I simplify, I'm going to get negative 2 over 0. Again, just like this one, 0's in the denominator, so this guy is an undefined number, or it's DNE. Okay, now the only type of line, okay, that has a slope that doesn't exist is a vertical line. Okay, so if this is a vertical line and this is a vertical line, okay, then they have to be parallel to each other. Okay, so parallel. Okay, and notice how they have the same slope. The slope is DNE and the slope is DNE. So if the slopes are the same, the lines have to be parallel. Okay, down to the last one. Got done with that guy. Down to this last one here. Okay. Do the same exact thing. I'll let this be line 1 and I'll let this be line 2. Okay, so I've got to do the slope of line 1 first. Okay, so slope delta y over delta x. Okay, so let's see. I'm going to go these guys minus these guys. Okay, so I go, my delta y would be 6 minus 6. And my delta x would be 0 minus 7. Okay, so I get 0 over negative 7. Okay, so we have 0 in the numerator. Okay, what's that mean? So it's like this. So if 0's in the numerator, this reduces down to 0. Okay, so that guy, 0 over negative 7, as a reduced fraction is just 0. So the slope of the first guy is 0. which going back here, anytime we have a zero slope, that means I have to have a horizontal line. So this guy has to be a horizontal line. Okay, then I do the second line. Okay, so I do my slope is delta y over delta x. Okay, and so let's see what I get here. I'm going to go these guys minus these guys. Okay, so my delta y would be 0 minus 10. And then when I do delta x, I go -4 minus a -4. Okay, so I'm going to get a -10 over 0. Okay, so again, going back here, what happens when zero's in the denominator? We get an undefined number, or DNE does not exist. Okay, so this slope does not exist. There's your slope right there. Now, what type of line has a slope that's undefined or doesn't exist? That's a vertical line. Okay, so this guy has to be a vertical line. Okay, so we go back here. I have a horizontal line and a vertical line. Well, clearly they don't have the same slope, so they can't be parallel. But notice what it says right here. If you have a vertical line and a horizontal line, they will always be perpendicular to each other. Okay, so I have a vertical line and a horizontal line, so they would always be perpendicular to each other. Okay, so that last pair, okay, we have perpendicular lines. Okay, and that wraps it up for today.